Welcome to another explainer. Today, we're diving into something that's literally going to change how you look at your daily commute. We're focusing on the hidden engineering holding us up. Think about it. We spend our lives moving vertically through cities, just blindly trusting our lives to these small suspended metal boxes, right? And we rarely give a second thought to the massive mechanical systems humming away just a few feet from our heads.
But let's be real for a second. Most of us have harbored that fleeting, visceral panic when stepping into a lift. You hear a slight creak or maybe feel a tiny shudder, and the questions just rush in. What if the cable snaps? What if we just free fall from the very top all the way to the bottom of the shaft, or get permanently trapped? It's a completely universal fear, and honestly, it's one that actually held back the vertical growth of our cities for a really long time.
So to cure that fear, we actually have to travel all the way back to 1854. Picture this. A guy named Elisha Graves Otis is standing on an open platform at the prestigious Crystal Palace Exposition in New York. In front of a huge, super tense audience, he gets hoisted high into the air and then does the unthinkable. He literally orders his only support rope to be cut with an axe. The lift fell a terrifyingly short distance before his brand new safety mechanism kicked in perfectly and the platform just locked in place. He shouted down to the crowd, "All safe, gentlemen," and that exact phrase remains the safety slogan for Otis elevators to this very day.
Now, looking at the history, Otis didn't actually invent the elevator itself. Primitive hoists and lifts had been around since like the 3rd century BC, moving heavy materials in warehouses and mines. But what he did was fundamentally shift them from being these risky freight platforms into trusted passenger transport by inventing the failsafe. He didn't just solve a physics problem, he solved the core issue of human trust.
Check out his official 1861 patent drawing here. This was the mechanical answer to that deeply human fear. Basically, during normal movement, the tension of the hoisting rope kept the safety parts unlocked. But, and here's the game changer, if that rope were to break or lose tension, a spring and pawl arrangement would instantly snap into action, catching onto toothed guide racks on the sides of the shaft. Suddenly, a lifted platform no longer depended solely on an intact rope.
Section 1. How elevators actually work.
Alright, so now that we know why we won't instantly plummet if a single rope breaks, let's see how modern engineering actually moves us between floors day in and day out. We've got two primary types of lifts today. On the left is the traction lift. This is where the lift car is suspended over a winding machine by wire ropes, with a heavy counterweight attached to the other side to assist the machine and give it traction. Then on the right, you have the hydraulic lift, which takes a completely different approach. Here, the car is literally pushed up from below, attached to a hydraulic cylinder, where the piston is raised and lowered by pressurized fluid.
Which brings us to Section 2, the need for speed.
Hydraulic lifts are incredibly reliable, for sure, but they're typically limited to low-rise buildings. Why? Because when it comes to covering serious vertical distance, traction lifts completely leave them in the dust. Vertical velocity scales up drastically based on the technology and how tall the building is. We go from a pretty sluggish 0.63 meters per second in a standard low-rise hydraulic, up to 1.6 in a medium-rise traction, past 2.5 for high-rises, all the way to an absolutely mind-blowing 17 meters per second for the world's elite skyscrapers.
To put that top speed into perspective, just look at the 508-meter Taipei 101 Tower in Taiwan. It's one of the tallest buildings in the world. Its elevators rocket passengers from the very bottom to the very top in just 30 seconds, hitting peak speeds of 38 miles per hour or 61 kilometers per hour. You are essentially traveling at highway speeds straight up into the sky. It's wild.
Section 3. Foolproof safety features.
Look, traveling at 38 miles per hour vertically means you absolutely need incredibly rigid mechanical fail-safes. The safety codes have evolved so much since Otis's day to ensure absolutely nothing goes catastrophically wrong. For traction lifts, engineers use this super clever device called an overspeed governor. If the car goes too fast, like exceeding its preset parameters, the centrifugal force of a rotating roller throws it right out of its groove. This physical movement immediately strikes a trigger, which pulls in the safety gear, violently and securely jamming the entire lift car directly into its rigid guide rails.
And here is something I find fascinating. Engineers actually have to account for human physics during an emergency stop. They tailored the safety gear to the speed of the elevator itself. For slower lifts up to 0.63 meters per second, they use instantaneous gear, so a hard, immediate halt. But for anything faster, they have to use progressive safety gear. This applies braking force gradually. Because think about it, if a lift going 38 miles per hour stopped instantaneously, the stop itself would severely injure everyone inside.
Now, hydraulic lifts handle emergencies a bit differently.
Since the car is sitting on a solid column of fluid rather than hanging from ropes, the main risk is losing that fluid pressure. To counter this, a pipe rupture valve sits directly at the base of the hydraulic ram. If the pipe leading to the cylinder fractures, this valve instantly detects the sudden drop in pressure and the increased flow. It snaps shut immediately, stemming the fluid flow and safely locking the lift exactly where it is.
But beyond the dramatic freefall stuff, lifts also protect us from everyday accidents with this sort of invisible web of safety features we totally take for granted. Mechanical and electrical interlocks are working simultaneously to ensure the car literally cannot run unless all the doors are completely sealed shut. Plus, mechanical locks stop you from opening the door from the inside unless the platform is perfectly level with the floor. Add in those electronic infrared edges that sense an arm or a leg and reopen before crushing it, and you're basically surrounded by overlapping safety nets.
Moving on to Section 4, Real Risks versus Hollywood Myths. So, with all these instantaneous governors, progressive brakes, and pressure rupture valves, what is the deal with those terrifying elevator disasters we constantly see in pop culture? Well, the simple truth is, the catastrophic, free-falling elevator plummeting down a dark, endless shaft is purely a Hollywood myth. It directly contradicts the laws of mechanical engineering and the redundant safeguards that have been standard for over a century. A modern elevator just cannot fall the way movies show it, period.
Actually, when serious incidents do happen, the data shows they're almost exclusively confined to installation and maintenance. The real hazards are faced by the professionals navigating active construction sites, who often have to temporarily short out or bypass those safety circuits to do their jobs on partially installed lifts. For you and me, the general public, the most common accident is literally just getting a brief bump from a closing door.
And finally, Section 5, Safest Transport in the World.
Let's lay out the hard statistical reality here, which officially crowns the elevator as the single safest way to travel on Earth. Every single year, according to the national elevator industry, people in the US and Canada alone take an estimated 210 billion elevator rides across roughly 700,000 different machines. That is just an astronomical number of trips happening completely silently in the background of our cities.
Breaking that down, it equates to roughly 325 million passengers being moved safely every single day. When you look at those figures, if you exclude private cars, elevators are moving more people daily than the sum total of all other forms of public transport put together. Airplanes, trains, buses, none of them even come close to the sheer volume and flawless safety record of the elevator.
So knowing all this, knowing that millions of invisible mechanical fail-safes are flawlessly catching, releasing, monitoring, and breaking billions of times a year, I've got to ask, do you still feel anxious when those doors slide shut? Or are you actually reconsidering taking the stairs? Because statistically speaking, the stairs are vastly more dangerous. Thanks for joining me on this explainer, and next time you step into a lift, take just a second to appreciate the magnificent hidden engineering holding you up.